All right. Section 3, refraction and lenses. Refraction, objects that are in water can sometimes look strange. A pencil in a glass of water sometimes looks as if it's bent, or as if the part of the pencil in the air is shifted compared to the part in the water. A penny that can't be seen at the bottom of a cup suddenly appears as you add water to the cup. Illusions such as these are due to the bending of light rays as they pass from one material to another. What causes light rays to change direction? Speeds of light. The speed of light in an empty space is about 300 million meters per second. Light passing through a material such as air, water, or glass, however, travels more slowly than this. This is because the atoms that make up the material interact with the light waves and slow them down. Figure 15 compares the speed of light in different materials. If you remember back to last week in class, I zoomed in with my camera and showed you that pencil in the water, and we talked about how the pencil looks as if it's in different spots because the light travels slightly slower as it passes through the glass and water, as opposed to the pencil that was sticking up in the air. So just that little change of speed makes that pencil look as if it's in different positions. Refraction of light waves. Light rays from the part of the pencil that's underwater travel through water, glass, and then air before they reach your eye. The speed of light is different in each of these mediums. What happens when a light wave travels from one medium into another in which its speed is different? If the wave is traveling at an angle to the boundary between the two media, it changes direction, or bends. This bending is due to the change in speed the wave undergoes as it moves from one medium into another. The bending of light waves due to the change of speed is called refraction. Figure 16 shows an example of refraction. The greater the change in speed is, the more the light wave bends or refracts. Why does a change in speed cause the light wave to bend? Think about what happens to the wheels of a car as they move from pavement to mud at an angle. The wheels slip a little bit in the mud and they don't move forward as fast as they do on pavement. The wheel that enters the mud first gets slowed down a little bit, but the other wheel on the axle continues at the original speed. The difference in speed between the two wheels can cause the wheel axle to turn, so the car turns a little. The light waves behave in the same way. Imagine again, in a light wave traveling at an angle from air into water, the first part of the wave to enter the water is slowed, just as the car wheel that first hit the mud was slowed. The rest of the wave keeps slowing down as it moves from the air into the water. As long as one part of the light wave is moving faster than the rest of the wave continues to bend. Convex and concave lenses. Do you like photographing your friends and family? Have you ever watched a bird through binoculars or peered through something tiny like a magnifying glass? All these activities involve the use of lenses. A lens is the transparent object with at least one curved side that causes light to bend. The amount of bending can be controlled by making the sides of the lens more or less curved. The more curved the sides of a lens are, the more light will be bent after it enters the lens. Let's take a look. Here's our convex. As you remember from the mirrors stuff earlier in the week here, a convex lens, okay, convex, remember bending out. So as the light waves are going towards the convex lens, it enters that glass or that lens, and then it will be bent inward. So all light waves, as they enter, are bent, and those all go past one area right here where it's in focus. Just like a magnifying lens or glasses that people have too. There's different prescriptions for glasses. because you want to be able to focus on something or see it better. All right. So convex lenses, a lens that is thicker in the center than at the edges, is a convex lens. You see how up here it's thickest in the center, and it's not quite as thick on these little edges out here. In a convex lens, light rays traveling parallel to the optical axis are bent, so they meet at a focal point, just like I was pointing out before. The more curved the lens is, the closer the focal point is to the lens, and so the shorter the focal length of the lens is. Because convex lenses cause light waves to meet, they're also called converging lenses. The image formed by a convex lens is similar to the image formed by a concave mirror. For both, the type of image depends on how far the object is from the mirror or lens. All right. Kind of go down here to, we're just mostly concerned here with trying to figure out what happens as light rays hit and interact with that medium and what it does with the light rays as it travel through. We won't get bogged down with the other things of the images here too. So concave, so here's the other one, the cave part. Remember we learned in the mirrors the cave is the one that goes inward, like this one kind of dips inward. You can see as the light waves are traveling towards that, and then once they strike that lens and they travel through, you see how it starts to get bent outward. Same here, as these are traveling, it strikes the lens as it starts to pass through. That curved surface will bend it outward. A lens that is thicker at the edges than in the middle is a concave lens. You can see it's a little bit thicker right here, and it's mostly thin in the center. A concave lens is also called a diverging lens. So diverging means to spread apart, just like you see here. These are spread away. Figure 19 shows how light rays traveling parallel to the optical axis are bent after passing through a concave lens. A concave lens causes light rays to diverge, so light rays are not brought to a focus. This type of image that is formed by a concave lens is similar to one that is formed by a convex mirror. The image is upright and smaller. I'm going to skip through that part here and optical fibers. So really that's, we're gonna skip over those parts too. The main thing that you need to know about the lenses mirrors part is basically what happens to the light as the light travels to it. What happens when it strikes. So the concave will spread that light outward, and again up here for the convex, it will strike and it will bring it towards that focal point here. So